Alright guys, welcome back to Algebra 2 Virtual, and we're talking about matrix division. I left you off with this problem here. I asked you guys to prove to yourselves that this really is the identity matrix. So you did this multiplication, and if you'd practiced your multiplication of matrices before, I think you found it pretty easy. Right? So you got that to work out, then this multiplication produced this same matrix back again, 1, 2, 3, 4, 5, 6. Alright, so what would we do if we wanted to do the same thing, preserve the identity of the matrix, but for a much larger matrix? If we put 1, 0, 0, 1 here, that wouldn't work, because that would be a 2 by 2 multiplying a 4 by 4, so that's just not going to work. So we need to sort of somehow figure out what to do in a situation like that. It's going to look an awful lot like this thing, but it's going to have to be bigger. What dimensions is this going to have if it's going to multiply by a 4 by 4 to give us another 4 by 4? Right? In order to multiply, it has to be a something by 4, but it has to be a 4 by 4 because this is also a 4 by 4. Right? So the inner numbers determine whether they can multiply, and the outer numbers determine the dimensions of the result. So this is going to have to be a 4 by 4 again. What do you think it's going to look like based on your experience with this thing? Right? We know there are going to have to be some 1s somewhere and some 0s somewhere. So this same pattern is going to repeat itself. The 1s are going to have to be along the diagonal that goes from top left to bottom right. So this thing is going to have 1s along the diagonal like that. And as you figured out when you did your multiplication with the 2 by 2 identity matrix, these 0s are important too, so that things don't get too mixed up. So that is the 4 by 4 identity matrix. And I think now you can probably see how to make an identity matrix of whatever size you need. It's always going to be a box, a square box, so 4 by 4, 7 by 7, 2 by 2, whatever, with 1s along the diagonal like that, from top left to bottom right, and 0s everywhere else. Okay, so this is kind of a matrix version of a 1. It's called the identity matrix. We give it the symbol I, and it's like a fancy 1. Okay, you multiply it by a matrix, and it doesn't do anything. Alright. So now that we know what the identity matrix is, we can move on and do some other things, getting closer to something that's actually going to feel like division. Right? When we add things, when we add two numbers together and they give us 0, this identity number for addition, this has to be the opposite of this. Right? You solve that for x and you find that x is -5. And we use the word opposite to describe the relationship between 5 and -5. With division and multiplication, when we multiply two numbers and we get 1, the identity number for multiplication, we call this other number the reciprocal. 1 over 13 is the reciprocal of 13. But they're both kind of the opposite. I guess a better word would be the inverse. This is the additive inverse of 5, and this is the multiplicative inverse of 13. Alright, so with matrices, we want to now figure out the same kind of thing. If I have a matrix like this, and I multiply it by another matrix, and I get the identity matrix, which is like 1, what does this matrix have to look like? Okay, so what's the relationship between this and this? Here they were opposites, here they were reciprocals. So how do these two things relate to each other so that I multiply them together to get the identity matrix? Okay? So this is going to be what we call the inverse of this matrix. It's kind of like the opposite or the reciprocal, except we're going to use the word inverse to describe it. Okay? Now I've done this before, so I know what this matrix X has to look like. I think I know. 5, -3, -3, 2. I picked an easy one. Alright, now you don't know how to find this yet, but I'm going to teach you in just a minute. But what I want you to do now is I want you to stop this, pause this, and test it out. See if it works. Is it really true that when we multiply this original matrix 2, 3, 3, 5 by what I'm calling the inverse, 5, negative 3, negative 3, 2, do we really get 1, 0, 0, 1? Okay? Does this really work out? So I'd like you to stop this movie and try that now. Right, so I think if you did what I asked, you found that this actually does work. That the multiplications work out and you get a 1, 0, 0, 1. You get the identity matrix. So that means that these two matrices are inverse matrices of one another. In the book it says something like B is the inverse of A, which can be written this way, if they multiply together to give the identity matrix. So if this is A and this is B, B is the inverse of A. We could just as well say that A is the inverse of B. They are inverses of each other. They multiply to give this identity matrix just like 13 and 1 over 13 multiply to give 1, just like 5 and negative 5 add to give us 0. Okay? So that's the idea of an inverse matrix. Now, in the next part of this, I'm going to show you what an inverse matrix can do for us, why we care, and then I'm going to show you, in the next part, how to find an inverse matrix of any 2 by 2 by hand, and then eventually how to find any inverse matrix using your calculator, because in the end, that's definitely the way to go. Alright, so for now, that's it, and I'll see you in part 3.